For question 2, we have to find the volume of this lake with the given depths and lengths and heights. And in order to do that, we have to find the volume of a rectangle, which is volume equals length times width times height. And then by multiplying everything, I did the top row first. I multiplied 10 times 8 times 3 all the way across to get to 1,040 feet cubed. And then we have to add that to the multiplication of the bottom 4 sections, which gets to 6,650 feet cubed, and adding those together, we can get our final answer of 7,690 feet cubed. And we must remember that this is not an exact answer. This is actually just an approximation, because as you can see, not every single section is a identical rectangle. So this is more like a Riemann sum approximation of volume, and then that is how we can find that answer.
So you can separate this double integral if you can manage to separate an f of x and a g of y, and then apply the appropriate bounds to them. So in this case, you can separate y squared over 1 from this total equation, so you get this. So you get y squared dy times x over x squared plus 1 dx, and then you apply the appropriate bound to this. So since it's dy dx, you first apply the integral from c to d, the bound c to d for y, and then the bound a to b for x. So you can only do this if you can manage to separate an f of x and a g of y, and then those respective functions only contain x for f of x and then y for g of y.
Okay, so for question 4, we start out with this. Then we find the new bounds, and we get 0 to 5 and 0 to x over 5. We then integrate in terms of y. We plug in the bounds x over 5 and 0. We get this as our product. Then we simplify that to this. And then we integrate in terms of x as seen here. We do u sub, u equals x squared, du equals 2x, du over 2 equals x. We also take out the 1/5, and then we also take out the half after. And then we just have this left to integrate. We have 1/10 e to the x squared with the bounds 5 and 0, which we plug in. We plug them in, 1/10 e to the 25 minus e to the 0, which is 1. And that's our answer, e to the 25 minus 1 over 10.
Okay, for question 9, you get this double integral. And when you're first trying to solve it, finding the integral of cosine y squared is very difficult. So the first thing you have to do is swap the order of the integrals, and that involves first plotting what the boundaries would be, and in this case y equals x squared and y equals 9, where it goes from 0 to 3 on the x-axis. And you get this order, and by taking the integral, you get x squared cosine y squared over 2. And then solving it all out, you get to here where you have to use u substitution, and then follow that through, and in the end you get sine of 81 all over 4.